is 8.6 part 2, and this is just on graphing quadratic functions continued. So again, take these notes on graph paper. And the first thing we're going to do is just look at a couple of graphs on Desmos again, kind of like I did on the last notes. So we're starting with right here, you can just see the graph of, you don't have to draw this, x squared. So it's our normal parabola, opens up, it's our parent function, it's like the normal one. Now if we change that, remember yesterday we like put the parentheses around the x and added or subtracted stuff to it and it shifted it left or right? Now, if you see what I'm going to do over here, I'm not putting this number in parentheses, the plus 1. I'm putting it after the x squared. So let's see what that does to the graph. So we can see, let me zoom out a little bit here, that it shifted. I've got my red one, and then the purplish one is the x squared plus 1. It looks the same, it just shifted it up 1. So it actually moved its vertex up 1. Still has this y-axis as the axis of symmetry. If I take that off, and instead I'm going to do x squared minus 5, you can maybe guess what's going to happen. It shifted it down 5 units. So if I add or subtract something onto the end of my quadratic function, it's going to shift it either up or down. Adding a number is going to shift it up. Subtracting a number or adding a negative is going to shift it down. So let's write that down in summary. So we're going to write something now that's like really, really important. So I wrote this kind of big because we're going to draw a bunch of arrows to this equation. So this is going to be the general equation for a quadratic that we graph. F of x equals a times x minus h squared plus k. So we're going to put arrows next to all these things and say what they can change about our graph. Remember, f of x equals x squared is our parent function. That's the normal one. It's the first one we graphed yesterday. Normal parabola, nothing is shifted, nothing is stretched, nothing is shrunk, it's not flipped, it's just normal. So this a out in front, if I'm multiplying my x squared by something out in front, if my a is greater than 1, it makes it narrower, like 2x squared. If my a is less than 1, like 1/2 x squared, it makes my graph wider. And if my a is negative, the graph is flipped. So it is a frown. So that's what that a in front can do. It can make it narrower, wider, or it can flip it. This part, the part that's in the parentheses with the x. If I see an x minus h, it's going to shift my graph h units to the right. So if I see a minus in there, it's going to shift it right. If I see an x plus h in there, it's going to shift my whole graph. That's a translation, as you might remember from last year, h units to the left. So the number inside the parentheses with the x can shift it left or right. Does not stretch or shrink it any narrower or wider, just shifts it left or right. And then lastly, this k on the end, excuse me, that k on the end, if I see a plus k, it's going to shift it up k units. And if I see a minus k, it's going to shift it down k units. So it's everything that can happen. You want to remember all this. The a in front can make it narrower or wider or flip it. The part in the parentheses with the x can shift it left or right. The part added on or subtracted on the outside can shift it up or down. So first, we're going to graph a parabola that is shifted a little bit. So, oh, we already did that. So for our first one, we are going to graph g of x equals, I'm going to run out of room here, x minus 3 squared, and then minus 5 on the outside. So, what you want to remember from what we just wrote is that this minus 3 is going to shift it 3 units to the right. this minus 5 is going to shift it 5 units down. So think about our regular parabola from yesterday. What you want to remember about this, I'm going to do it in gray on here, maybe you could draw it lightly on your paper, is it had a vertex at 0. If we do 1 and square it, so x is 1 and you square it, it's 1, and that mirrors on the other side. If you go over to x is 2 and square it, you get 1, 2, 3, 4, and that is mirrored on the other side. So this is what x squared looked like. So now all we're going to do is take that same exact graph, but we're going to shift it 3 units to the right and 5 units down. 1, 2, 3, 4, 5. So our new vertex is right here. So our new vertex is at 3, negative 5. And that's actually going to be part of this problem. I forgot to write it down. But we want to find the vertex, and it is at 3, negative 5. Now we need to graph it. So what we're going to do is this same pattern we saw on the gray graph. If we go over 1 in either direction, we go up 1. So over 1, up 1. And then I'm going to go to the left one and go up 1. Because 1 squared, I just go up 1. Now if I go 2 over, I need to go up 4 because I'm squaring it. So 2 over, I go up 1, 2, 3, 4 from the vertex. And same in the other direction. If I go 2 over from the vertex to the left, I need to go up 4. So this looks messy because of all these arrows I put on it, but there is our graph. It's the same as x squared, but it's shifted right 3 and down 5. The other part that this problem is asking is it wants us to find a minimum value. That just means what's the lowest value of the graph? The lowest y value is what they mean. Whenever they say what's the value of this graph, they want to know the y. So the lowest y value of this graph is down here at negative 5. So the minimum value is negative 5. So those are two other things they're going to be asking you about. To graph it, tell the vertex, tell the minimum value. All right, pause if you need more time. I've got 2 more examples to do. So our second one, we are going to graph h of x equals 1 half times x minus 3, squaring it, and then we're going to add 6. So let's talk about what all these parts of this function mean in terms of this. So the plus 6 at the end, hopefully you know now, that means it's going to shift up 6. The minus 3 in the parentheses means that we're going to shift to the right 3. We're going to shift the vertex and every point on the parabola, actually. And then this 1 half out in front means that it's going to look wider than our parent function, x squared. So here's the kind of bad thing. You know how on the last one I didn't make you make an XY chart because we just knew it just shifted left and right and up and down? Okay, anytime it gets wider or narrower, you have to make the XY chart. Sorry. So let's make an XY chart. It's not going to be too bad. My rule is that you have to have at least 5 points. So you need the vertex and at least 2 points on either side of the vertex. So if you think about it, we know what the vertex is right now. It's usually at 0, 0. Now it's going to the right 3. So that's going to change the x value of our vertex to 3. And it goes up 6, so it's going to change the y value of our vertex to 6. So you can see right here, I just put whatever comes after the minus sign right there, or I put the opposite of the number I see. So I see a negative 3 there. That means my vertex x value is 3. And then for my vertex's y value, it's at 6 just because I know that I see a 6 at the end of that. So that's how you can always find the vertex, because we know how it's shifted. So since we know that, let's try just going a little bit on either side of the vertex. So let's just go a little bit lower than the vertex. Let's try 2 and 1. I know I'm not doing this in order, but it's a little bit easier to work around the vertex. So if I plug in a 2 here, that means I'm doing 1 half of 2 minus 3 squared, and then I'm adding 6. So let's see. 2 minus 3 is negative 1. Square it. That's 1 times a half. That's a half. Plus 6. That's 6 and a half, or 6.5. Let's plug in the 1. So that means we're doing 1/2 of 1 times 3 squared plus 6. So let's see, 1 minus 3 is -2. Squaring that, that's 4. Times 1/2, that's 2. Plus 6, that's 8. Now, what we know about parabolas is that they're the same on either side of the vertex. So since I know that this one was my vertex, that's what I started with, I found how far it shifted right and up. I can just go on the other side. So I went 1 lower for the 2. So let's go 1 higher. That's going to match up with the 2 because the 2 is 1 lower. Since this one is 1 higher, it's going to match up with the 2. So it's also going to be 6.5 because I make a perfect U here. And then if I go, okay, from the 3 to the 1, that was 2 lower. So if I go up 2 to 5, so I'm moving up 2 x values from my vertex, that's going to match up with this 1 because it was 2 x values lower than my vertex. So it's going to also be 8. And I hope you guys have questions about this when you come back, because I know it's probably not extremely clear on this video. So let's go ahead and graph all these points. So we've got 3, 6. So over 3, up 6. That should be our vertex. We've got 2, 6.5. So over 2, up 6.5. It's going to be the same on the other side. That's the point 4, 6.5. And then I know I go to 1, 5, 6, 7, 8. And then I can do the same on the other side, go over to 5, and I go up 8. So you guys can see that's been shifted right and up, and it's a little wider than our graph of x squared. Pause if you need more time. I've got one more example to do. So on this last example, we're going to graph let's see, y equals -2 times x plus 3 squared plus 5. So let's think about what all these things do to it. So the plus 5 means that we're shifting it up 5. The plus 3 means we're shifting it to the left 3. The 2 in front means it's becoming narrower. And the negative in front means that it flipped over, so it's a frown. So we have a general idea of what it's going to look like. We have to make an XY chart because it is stretched, it's narrower. So we are going to have to make an XY chart for this one, but we can use some properties that we know to start off with the vertex, and then we can work around that. So we know our vertex is going to be the opposite of what we see in here. So -3 is our x value, and then it's going to be what we see over here for the y value. It's shifted up 5, so it's going to move us 5 up the y-axis. So that's our vertex. You can put it on your graph if you want. -3, 1, 2, 3, 5. 1, 2, 3, 5. There we go. So let's work around that vertex. So let's go a little smaller than our vertex. So I'm going to do -4 and -5. You always want to do 2 values on either side of your vertex. 2 x values, find the y value. So let's plug in that -4. That means I'm doing -2 times -4 plus 3 squared plus 5. Whew, okay, let's see. -4 plus 3, that's -1. Squared is +1. Times the -2, that's -2, plus 5 is 3. Let's plug in the -5. So I'm doing -2 times -5 plus 3 squared plus 5 on the end. So -5 plus 3, that's -2. Square that, that's +4. +4 times the -2 is -8, plus 5 is, did I do that right? -5 is -3. Yeah, that's right. All right, so now we can use this trick that we went 2 spots lower than our vertex in terms of the x value. So like here, I went 1 lower. So now let's go 1 higher up to -2. It should match. So this should be a 3. It should match with this guy. So now instead of going 1 higher, over here we went 2 lower, so now we're going to go 2 higher to -1 from my x value. And so it should match up with the one that was 2 lower. That was -3. So they're matching up on either side of the vertex. And then let's graph those points. So we've got -3, 5. We already graphed that, or I did. -4, 3. So -4 up to 3. -5, we go down to -3. And then if we go on the other side, it should match. So see how those two match? And then we go here, matches. So you can see this one's narrower. Do your best to draw a nice curve. It flipped over, and it was shifted. So on this one, it's going to ask you a bunch of different things. I want to know the vertex. Well, that was at -3, 5. I want to know the axis of symmetry. That's just the vertical line that cuts it in half. So it's always going to be x equals, and this one is -3. It's right here. X equals -3. That's my axis of symmetry. And then it wants to know if it has a maximum or minimum value. Well, this one does not have a minimum. It goes down, 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 down forever and ever and ever. So it has a maximum value of 5. It's whatever the highest y value is at the vertex. All right, so that's our last example for today. Be prepared to do some examples and practice in class.